All right, a couple more examples to kind of walk through this. So the first example I want to look at is, let's find the composite function of the cosine of the inverse cosine of 0.6. So the first thing we want to find out is this is my roughly my x value, and I know that my solution will be that x value because what a composite function does, it undoes its inverse function and gets back to what we started with. So that's the case. So let's look at this 0.06. Is that in our already previously defined domain? Well, the cosine of the inverse cosine equals x, and for all values from -1 to +1. And 0.06, it's already in that defined domain, so I know that this evaluates to 0.6. Yeah, that's all you got to do. If it's in the domain, you have the answer already there. If you don't have the domain, then you need to ask a follow-up question. So, speaking of that, let's look at the next example. I have the inverse sine of the sine of 3 pi halves. So what are you asking yourself right now? You're asking yourself is this in already the restricted domain? So let's remember, we have the inverse sine of the sine of x equals x for all values between negative pi halves and pi halves. Well, unfortunately, 3 halves pi is not in that already restricted domain, so I can't automatically transfer that to my answer. So what I need to do, first of all, is I need to evaluate the sine of 3 pi halves. And what was its evaluation at? So I remember where the sine of 3 pi halves are. And I remember that the sine of 3 pi halves, it's in the second quadrant. Its value is -1. So now I can ask myself the next question. Here's the inverse, the inverse of sine, which is asking whose angle produces a -1 when I'm talking about sines. Whose angle produces a -1? And if I remember that, that was the angle of negative pi halves. So I can say then that the composite of the inverse function of sine of the sine of 3 pi over 2 is minus pi halves. And you're right, these two values are not the same look, but they are the same value if we understand it in terms of what the sine value is. They both produce the same sign. All right, the last example. Taking cosine and composite with the inverse cosine of 1.5. So let's go back and try to remember what our domain was. We're looking at the cosine of the inverse cosine. The domain was restricted from -1 to 1, just like our first example. However, I have a value of 1.5, which is not in the domain. And I can't manipulate that any type of way. That value is already completely outside the domain. So therefore, this does not have any solution, which is nice, meaning that we don't have to do a lot of work. We're already done. I know, how's that feel? Feels cool, huh?